What if every choice you've ever made, every decision, big or small, has spun off an entirely new reality? A version of you, somewhere out there, living a life completely different from your own. This isn't just the stuff of science fiction anymore. Parallel universes, once a wild idea confined to the pages of speculative novels, are now a serious area of scientific study. From the cutting-edge theories of quantum mechanics to the mind-bending possibilities of infinite realities, the concept of multiple universes is reshaping how we understand existence itself. What does it mean for our understanding of reality if there are countless versions of us out there, each living out a different path? Over the next few minutes, we'll dive into 20 astonishing concepts about parallel universes that are changing the very fabric of reality. These ideas will challenge your assumptions, spark your imagination, and maybe even leave you questioning the nature of your own existence, ready to explore the infinite. Let's begin. What if everything we know about reality is just one small piece of an infinite cosmic puzzle? That's the bold claim at the heart of the multiverse theory, a mind-bending idea that suggests our universe is just one of countless others, each with its own unique set of rules and possibilities. This concept didn't emerge from science fiction. It grew out of the deep, complex realms of quantum mechanics and cosmology. Physicists like Brian Greene have described it as a natural extension of our understanding of the quantum world, where particles can exist in multiple states at once. Max Tegmark, another leading voice in this field, has even proposed that the multiverse isn't just a theory but a mathematical inevitability, rooted in the fabric of reality itself. Imagine a reality where the laws of physics aren't fixed. In some universes, gravity might be stronger or weaker, light might travel at different speeds, or even time itself could flow in unpredictable ways. These universes might be so alien to us that they're almost impossible to comprehend. Yet, according to the multiverse theory, they could exist right alongside our own, separated by dimensions we can't perceive. It's a staggering thought, one that challenges everything we think we know about existence. And as we explore this idea further, it becomes clear that the multiverse isn't just a scientific curiosity. It's a gateway to even more astonishing possibilities, reshaping how we see the cosmos and our place within it. Now, let's take a step into the vastness of infinity. What if space isn't just big? What if it's truly infinite? If that's the case, then the implications are mind-bending. An infinite universe means there's no end to the possibilities. Every event, every outcome, every version of reality you can imagine, or even those you can't, exist somewhere out there. This is the foundation of the infinite universes theory, where the laws of probability and the sheer scale of the cosmos collide to create a tapestry of endless realities. Think about it. In an infinite universe, every possible combination of events must happen. That means there's a version of reality where dinosaurs never went extinct, where humans evolved with completely different traits, or where history unfolded in ways we can't even begin to fathom. The idea isn't just science fiction, it's rooted in mathematics and physics. If space goes on forever, and if matter is distributed evenly across it, then somewhere, somehow, every conceivable scenario must exist. It's not just a question of what if, it's a question of how many. But this concept doesn't just challenge our understanding of the cosmos, it challenges our sense of self. If there are infinite versions of you out there, each living a slightly different life, what does that say about your uniqueness? Are you one of a kind, or just one of countless variations? This is where philosophy meets physics, forcing us to confront questions about identity, purpose, and the nature of existence itself. Infinity isn't just a number, it's a doorway to infinite possibilities, and it reshapes how we see our place in the grand scheme of things. And speaking of reshaping reality, this leads us to the next mind-blowing idea, the role of quantum mechanics in parallel universes. What if the very building blocks of reality, tiny particles and their unpredictable behaviors, are the key to unlocking infinite worlds? Stay with us because the quantum realm is where things get even stranger. Quantum superposition is one of the strangest and most mind-bending ideas in physics, and it might just hold the key to understanding parallel universes. At its core, superposition tells us that particles, like electrons or photons, can exist in multiple states at once. Think of it like a coin spinning in midair. It's neither fully heads nor tails until it lands. In the quantum world, that coin could still be spinning, existing as both possibilities simultaneously. Now, here's where things get wild. If particles can exist in multiple states at the same time, what does that mean for the larger world? Enter Schrödinger's cat, the famous thought experiment that brings this idea to life. Imagine a cat in a box with a device that has a 50-50 chance of releasing poison. According to quantum mechanics, until you open the box, the cat is both alive and dead at the same time. It's only when you observe the system that one reality becomes real. But what if, instead of collapsing into a single outcome, every possible outcome continues to exist? That's the essence of the many worlds interpretation. It suggests that every time a quantum event occurs, like the cat being alive or dead, the universe splits into multiple branches. Each branch represents a different outcome, creating a new parallel reality. So, in one universe, the cat survives, and in another, it doesn't, but it doesn't stop there. This branching isn't limited to cats in boxes. Every decision you make, no matter how small, could create a new universe. Did you choose coffee over tea this morning? In another reality, there's a version of you sipping tea instead. Did you take a different route to work? Somewhere out there, another you is living that alternate timeline. What's truly astonishing is how these branching paths could lead to universes with completely different histories. A single quantum event billions of years ago might have set off a chain reaction, creating a reality where the dinosaurs never went extinct or where humanity never evolved. The implications are staggering. Countless universes, each with its own unique story, all existing simultaneously. And while we can't see or visit these parallel realities, the idea that they might exist challenges everything we thought we knew about the nature of existence. So, if quantum superposition is real and the many worlds interpretation holds true, then every moment is a crossroads, every decision a doorway to another world. But what happens when these branching paths lead to realities so different from our own that they're almost unrecognizable? That's where things get even more fascinating. What if the Roman Empire had never crumbled? Or if the Cold War had erupted into a full-scale nuclear war? These aren't just hypotheticals, they could be realities in parallel universes, where alternate versions of history play out in ways that challenge everything we think we know about cause and effect. The concept of alternate histories suggests that every major event, every decision, every twist of fate could have taken a different path, leading to entirely unique timelines. Imagine a world where the Roman Empire still stands today, shaping global politics, technology, and culture in ways we can barely fathom. Or consider a timeline where the Cold War escalated, leaving Earth a barren wasteland. These aren't just fascinating thought experiments, they're windows into the infinite possibilities of existence. Historians and physicists alike have pondered the implications of alternate histories. Renowned physicist Stephen Hawking once remarked that even small changes in the past could lead to drastically different futures. Think about it. What if a single battle, a single invention, or a single decision had gone the other way? Entire civilizations might have risen or fallen based on the tiniest shift in events. This idea forces us to rethink our understanding of history as a linear, unchangeable narrative. Instead, it becomes a branching tree with every possibility coexisting somewhere in the multiverse. But what makes alternate histories so compelling isn't just the what-if factor, it's how they challenge our perception of cause and effect. If every possible outcome exists in some parallel universe, then the idea of inevitability starts to unravel. Was World War II unavoidable, or could diplomacy have prevailed in another timeline? Could humanity have discovered the secrets of interstellar travel centuries ago under different circumstances? These questions don't just spark curiosity, they push us to examine the delicate balance of forces that shape our world. As historian Niall Ferguson once said, history is not just the story of what happened, but also of what might have happened. And speaking of what might have happened, let's not forget the role of black holes in this cosmic tapestry. These enigmatic objects, often described as the universe's ultimate mysteries, might hold the key to creating entirely new universes. But that's a story for the next chapter. What if the most mysterious objects in the cosmos, black holes, are not just cosmic vacuums but gateways to entirely new realities? This mind-bending idea suggests that the crushing gravitational forces within a black hole could tear the fabric of space-time, creating a bridge to another universe. Imagine falling into a black hole not to be destroyed, but to emerge in a completely different realm with its own laws of physics. It's a concept that sounds like science fiction, but it's rooted in some of the most groundbreaking theories in physics. Stephen Hawking, one of the greatest minds in theoretical physics, proposed that black holes might not be the one-way streets we once thought they were. Instead of being cosmic dead ends, they could act as tunnels, wormholes connecting our universe to others. The intense gravity of a black hole distorts spacetime so severely that it could potentially create a new spacetime continuum, birthing an entirely new universe. This idea aligns with the concept of a multiverse, where countless universes exist alongside ours, each with its own unique properties. But how could a black hole give rise to a new universe? Think of it like this: when matter is pulled into a black hole, it doesn't just vanish. Instead, it might be compressed to an unimaginable density, triggering a new Big Bang on the other side. This would mean that every black hole in our universe could be the seed for a brand new cosmos, expanding endlessly in its own dimension. It's a staggering thought. Every black hole, from the supermassive ones at the centers of galaxies to the smaller stellar remnants, could be a cosmic doorway. This theory also raises fascinating questions about the nature of reality. If black holes are portals, what would the universes they lead to look like? Would they have stars, planets, and life, or would their physical constants be so different that they're unrecognizable to us? And if every black hole creates a new universe, could our own universe have been born from a black hole in another cosmos? As we dive deeper into this concept, it's impossible not to wonder how these new universes might differ from our own. What if the laws of physics there were entirely alien, with gravity behaving differently or light traveling at another speed? This leads us to our next astonishing idea: the possibility of universes with entirely different physical constants, realities where the fundamental rules of existence are rewritten. What would that even look like? Let's explore that next. What if gravity in another universe was so weak that planets couldn't form? Or if the speed of light was a fraction of what it is here? This brings us to the sixth astonishing concept: parallel universes with entirely different physical constants. In our universe, the laws of physics are finely tuned. Gravity, electromagnetism, and the speed of light all work together in a delicate balance to create the conditions for life. But in another universe, these constants could be wildly different. Imagine a universe where gravity is so strong that even atoms are crushed into oblivion, or where the speed of light is so slow that time itself feels like it's crawling. In such places, the very fabric of reality would be unrecognizable, and life as we know it might be impossible. This idea isn't just science fiction. It's rooted in theories like string theory, which suggests that our universe is just one of countless possibilities, each with its own unique set of physical laws. String theory proposes that the fundamental strings of energy vibrating at different frequencies could give rise to universes with varying constants. Some of these universes might be chaotic and unstable, while others could have conditions so alien that even our best scientists would struggle to comprehend them. Now, if universes with different physical constants seem mind-bending, just wait until we explore the next concept: parallel universes existing in higher dimensions. What would it mean for reality if space itself had more than the 3 dimensions we're familiar with? What if our universe is just one slice of a much larger, multidimensional reality? This is the intriguing idea behind higher dimensional universes. We're used to thinking in 3 dimensions: length, width, and height, but what if there are more? Imagine our universe as a single sheet of paper. Now, picture an infinite stack of papers, each representing a separate universe, existing in a higher dimension we can't see or touch. These parallel realities could be stacked right alongside ours, separated only by dimensions we don't yet understand. Scientists theorize that these higher dimensions could explain phenomena that seem impossible in our 3-dimensional world. For example, gravity, which feels weak compared to other forces, might actually be leaking into our universe from one of these extra dimensions. It's as if the rules of our reality are just a small part of a much bigger, multidimensional framework. And if that's true, what else could be happening in those unseen layers? Entire civilizations, alternate laws of physics, or even versions of ourselves might exist there, completely hidden from our perception. But how could these higher dimensional universes interact with ours? One possibility is that they occasionally brush against each other, creating ripples or distortions in space-time. Think of it like 2 sheets of paper sliding past one another, just enough to leave a mark, but not enough to fully merge. These interactions could explain mysterious cosmic events, like sudden bursts of energy or unexplained gravitational waves. And while we can't yet detect these higher dimensions directly, their influence might be all around us, shaping the very fabric of our reality. This leads us to an even more mind-bending thought. What happens when these higher dimensional universes don't just brush past each other but collide? The implications could be as profound as they are terrifying, but that's a story for the next concept, where we'll dive into the explosive possibilities of universes crashing together. What if the universe we know isn't the only one out there, but instead it's just one of many, and sometimes these universes crash into each other? This is the mind-bending idea behind the concept of colliding universes. Imagine 2 bubbles floating in a vast ocean, drifting closer and closer until they meet. When they collide, the impact could be so immense that it sparks events on a cosmic scale, like the Big Bang itself. Scientists have theorized that such collisions might be more than just science fiction. In fact, they could leave behind clues like ripples in the cosmic microwave background, the faint afterglow of the universe's birth. These imprints might be detectable, offering us a glimpse into the existence of other realities beyond our own. Take, for example, the work of cosmologists studying anomalies in the cosmic microwave background. Some have proposed that certain irregularities, like cold spots or unusual patterns, could be evidence of a collision with another universe. It's like finding a fingerprint on a window pane, something unexpected that hints at a larger, hidden story. These cosmic breadcrumbs could be the key to understanding not only our universe but also the multiverse as a whole. The idea that universes can collide and reshape each other challenges everything we thought we knew about reality. It suggests that the cosmos is far more dynamic and interconnected than we ever imagined. But what drives these collisions, and how do they influence the fabric of reality? Some theories point to the role of dark matter, an enigmatic force that makes up most of the universe's mass yet remains invisible to us. Could dark matter be the thread that connects parallel universes, shaping their interactions and even their collisions? This brings us to the next fascinating concept, the role of dark matter in weaving the tapestry of parallel realities. Now, let's turn our attention to one of the most mysterious substances in the cosmos, dark matter. While it's invisible and doesn't interact with light, dark matter makes up about 85% of the universe's total mass. But here's where it gets even stranger. Some scientists believe dark matter could be the key to unlocking the secrets of parallel universes. Imagine, if you will, that dark matter isn't just hiding in our reality, but exists in overlapping dimensions, subtly influencing the fabric of our own universe. Astrophysicists like Dr. Lisa Randall have proposed that dark matter might be a bridge between our world and parallel realities. In her groundbreaking work, Randall suggests that dark matter particles could be interacting with forces from other dimensions, creating ripples that affect the gravitational pull we observe in our universe. This idea opens up a mind-bending possibility. What if dark matter isn't just a passive observer but an active participant in a multiverse? It's as if the universe is a grand symphony, and dark matter is the hidden conductor, orchestrating movements across multiple stages. To put it another way, think of dark matter as a cosmic messenger. Just as a letter can pass between two houses, dark matter might carry information or energy between parallel realities. This could explain why we detect its gravitational effects but can't directly see or touch it. It's operating on a plane beyond our immediate perception, hinting at a much larger, interconnected multiverse. As physicist Brian Greene once said, "The universe may not just be stranger than we imagine, it might be stranger than we can imagine." This theory doesn't just challenge our understanding of dark matter, it redefines our place in the cosmos. If dark matter truly connects us to other universes, then every galaxy, every star, and even every atom in our reality could be part of a vast, multidimensional network. The implications are staggering. What we perceive as our universe might just be one thread in an infinite cosmic tapestry. And speaking of infinite possibilities, this brings us to our next concept, the tantalizing idea of time travel through parallel universes. Could the very fabric of dark matter hold the key to traversing not just space but time itself? Stay with us as we explore this extraordinary frontier. Could parallel universes hold the key to unlocking the mysteries of time travel? Surprisingly, the idea of moving through time might not just be a one-way street confined to our own universe. By branching into alternate realities, we could potentially navigate the past and future without breaking the rules of causality. Here's how it works. In a multiverse framework, every decision creates a new timeline, meaning that traveling back in time wouldn't change your original universe, it would simply shift you into a parallel one. This elegantly sidesteps classic paradoxes like the grandfather paradox, where changing the past would erase your own existence. Instead, you'd be stepping into a new reality where your actions create a fresh, alternate timeline. Science fiction has long explored this concept with stories like Doctor Who and Marvel's What If series showcasing characters hopping between timelines. But it's not just fiction. Some physicists suggest that parallel universes could provide a theoretical playground for time travel, where the laws of cause and effect remain intact. For example, if you traveled back and prevented a historical event, you wouldn't erase it from your original timeline. You'd simply create a new one where that event never occurred. This idea offers a fascinating way to reconcile time travel with the laws of physics, opening up possibilities that once seemed impossible. And speaking of the impossible, What if time itself could flow differently in other universes? Imagine a reality where entropy, the natural tendency toward disorder, runs in reverse. This isn't just a wild thought experiment. It's a concept that could redefine our understanding of the cosmos. Let's explore that next. What if, in some parallel universe, time itself worked backward? Picture a world where entropy, the natural tendency of systems to move from order to chaos, decreases instead of increases. In our universe, spilled milk never jumps back into the glass, and broken eggs don't reassemble themselves. But in a reversed entropy universe, these everyday impossibilities might be the norm. Here, effects could precede causes, creating a reality where the future influences the past. This isn't just a wild thought experiment. It's a concept rooted in the laws of thermodynamics. In thermodynamics, entropy is often described as a measure of disorder. Our universe follows the second law, which states that entropy always increases over time. But in a reversed entropy universe, that law would flip. Imagine watching a movie in reverse. Shattered glass reforms, smoke condenses back into a fire, and rivers flow uphill. In such a reality, the arrow of time would point backward, and our understanding of cause and effect would be turned on its head. This reversal would have profound implications. For instance, a person in this universe might experience their life starting at death and moving toward birth. Events that seem random to us might appear predestined there as the future shapes the past. Even our concept of free will would be challenged, as decisions could be influenced by outcomes that haven't happened yet. It's a mind-bending idea that forces us to rethink everything we know about reality. Now, while reversed entropy universes stretch our imagination, they also open the door to another fascinating concept: simulated universes. What if the reality we perceive isn't the base layer of existence, but a carefully constructed simulation? This idea takes us into the realm of digital realities, where entire universes could be programmed into existence, but that's a story for the next concept. What if everything we know, every star, every galaxy, even our own existence, is nothing more than lines of code in a vast cosmic simulation? This is the radical idea behind simulated universes, a theory that suggests our reality might be an artificial construct meticulously designed by some advanced civilization. Think of it like a video game, but one so intricate and detailed that we, the players, can't tell the difference between the simulation and what's real. And if that's true, then it opens the door to the possibility of countless other simulated universes, each running its own unique version of reality. Philosopher Nick Bostrom famously explored this idea, proposing that if a civilization reaches a level of technological sophistication capable of creating such simulations, it's statistically likely that we're living in one of them. After all, if you could simulate entire universes, why stop at just one? You'd create millions, billions, even trillions of them. This raises profound questions about the nature of existence. Are we just characters in someone else's grand experiment? And if so, what does that mean for free will, purpose, and the very essence of reality? From a scientific perspective, the simulation hypothesis isn't just a thought experiment, it's a testable idea. Some researchers have suggested looking for glitches or patterns in the fabric of the universe that might hint at its artificial origins. For instance, if space-time has a finite resolution like pixels on a screen, we might one day detect it. Others argue that the laws of physics themselves could be the rules of the simulation, carefully coded to keep everything running smoothly. But perhaps the most intriguing aspect of simulated universes is how they blur the line between creator and creation. If we're living in a simulation, then the beings who designed it might themselves be part of another simulation, and so on, creating an infinite regress of realities within realities. It's a dizzying thought, but one that forces us to reconsider our place in the cosmos. And if reality is shaped by simulations, what role does consciousness play in all of this? Could our minds be the key to unlocking the true nature of these parallel worlds? That's where our journey takes us next, into the fascinating intersection of consciousness and the multiverse. What if the very act of observing the world around us could shape reality itself? This brings us to the 13th concept, the intriguing relationship between consciousness and parallel universes. Some theories propose that our awareness, our ability to observe and perceive, might be the key to determining which version of reality we experience. Imagine for a moment that every possible outcome of a quantum event exists simultaneously, like a vast, branching tree of possibilities. According to the many worlds interpretation, these branches represent parallel universes, each one a unique reality. But here's where it gets even more fascinating. The act of observation could act like a spotlight, collapsing these infinite possibilities into a single, tangible reality that we experience. This idea draws heavily from quantum mechanics, where particles exist in a state of probability until they are observed. Take the famous double-slit experiment, for example. When particles like electrons are fired at a barrier with two slits, they behave as both particles and waves until someone observes them. At that moment, their wave-like behavior collapses and they settle into a single, measurable state. Some scientists speculate that consciousness itself might be the mechanism that forces these quantum probabilities to resolve into a concrete reality. If that's true, could our minds be the bridge between the infinite potential of parallel universes and the world we perceive as real? And if consciousness plays such a pivotal role, what does that mean for the other yous in those parallel universes? Are they experiencing entirely different realities based on their own observations? This theory opens up a universe of questions about free will, perception, and the nature of existence itself. It challenges us to rethink not just how we see the world, but how we shape it consciously or unconsciously. Now, as we ponder the profound connection between consciousness and reality, let's shift our focus to the next mind-bending idea: universes where multiple timelines coexist, intertwining and diverging in ways that defy our understanding of time itself. What happens when past, present, and future collide in a single cosmic dance? Stay with us as we explore this captivating concept next. What if every decision you've ever made created an entirely new universe? This is the idea behind multiple timelines, one of the most fascinating concepts in the study of parallel universes. Imagine a single moment in history, say, you chose to take a different route to work one morning. In one timeline, that decision leads to a series of events that change your life. But in another, your original path unfolds as usual. These branching timelines suggest that every choice, no matter how small, could spawn an entirely new reality. It's a concept that's been explored in countless science fiction stories, from the alternate realities of Sliding Doors to the time-bending adventures of Doctor Who. But is there any scientific basis for this idea? Some theories in quantum mechanics suggest that every possible outcome of an event could exist simultaneously, each in its own separate timeline. This is where the butterfly effect comes into play. A small change, like the flap of a butterfly's wings, could ripple out and alter the course of history in ways we can't even imagine. While this might sound like pure fiction, some physicists argue that the mathematics behind quantum theory leaves room for the possibility of multiple timelines coexisting alongside our own. Now, if you think that's mind-bending, consider this. What if some universes don't even follow the rules of time as we know them? What if there are realities with no beginning, no end, and no linear progression at all? This is where our journey takes us next, into the mysterious realms of universes that defy our understanding of time itself. What if time, as we know it, doesn't apply everywhere? Imagine a universe where the ticking of clocks fades into irrelevance, where beginnings and endings are replaced by an unbroken, eternal flow. This is the concept of eternal universes, parallel realities that exist in a state of perpetual equilibrium, untouched by the constraints of time. Unlike our own universe, which began with the Big Bang and may one day face heat death, these eternal universes defy the very notion of a start or finish. They simply are, existing in a timeless loop or a static state that challenges everything we think we know about causality and the nature of existence. To understand this, let's turn to cosmology. Some theoretical models, like the steady-state theory, propose that the universe could maintain a constant density over time, with matter continuously created to fill the gaps left by expansion. While this idea has fallen out of favor in our own universe's context, it sparks fascinating possibilities for parallel realities. In eternal universes, time might not flow linearly. Instead, it could loop back on itself, creating endless cycles of creation and renewal. Or it might not flow at all, existing as a single, unchanging moment stretched across infinity. This raises profound questions about causality. In our world, cause precedes effect, and time's arrow points in one direction. But in an eternal universe, cause and effect could become meaningless. Events might not follow a sequence, but instead exist simultaneously, like a tapestry woven from every possible moment at once. It's a mind-bending thought, one that forces us to reconsider the very fabric of reality. And while this concept stretches the limits of our imagination, it also opens the door to even more extraordinary possibilities, like universes where life takes forms we can scarcely comprehend. But that's a story for the next chapter. What if life as we know it is just one possibility among countless others? In some parallel universes, the conditions for life might have taken a radically different path, giving rise to forms of existence that defy our imagination. Picture a universe where gravity is stronger and creatures have evolved with exoskeletons to withstand the crushing pressure. Or consider a reality where the atmosphere is dense with methane and life thrives in ways we can barely comprehend. These universes could host beings that communicate through bioluminescence, navigate using magnetic fields, or even exist in dimensions beyond our perception. Astrobiology offers us a glimpse into how life might adapt to extreme environments, from the methane lakes of Titan to the icy oceans of Europa. But in parallel universes, the rules of chemistry and physics themselves might be different, opening the door to life forms that are truly alien, not just in appearance but in their very essence. Imagine a universe where DNA is replaced by an entirely different molecule, or where consciousness arises from structures we can't even begin to describe. These possibilities challenge our understanding of what life even means. And as we ponder these extraordinary scenarios, it's worth asking, could quantum entanglement, the mysterious link between particles across vast distances, also connect these alien realities? That's a question we'll explore next, diving into how the strange phenomena of quantum mechanics might bridge the gap between parallel universes. What if the very fabric of reality is stitched together by invisible threads, connecting not just particles but entire universes? This is the mind-bending idea behind quantum entanglement and its potential role in linking parallel worlds. At the quantum level, particles can become entangled, meaning their properties are intertwined no matter how far apart they are. Change one particle, and its entangled partner instantly reflects that change, even if they're light years apart. It's as if they're whispering secrets across the cosmos faster than the speed of light. But here's where it gets even stranger. Some physicists theorize that this entanglement might not just span distances in our universe, it could connect particles across different realities. Imagine two entangled particles, each existing in a separate parallel universe, yet still influencing each other in ways we can't fully comprehend. This could mean that parallel universes aren't just isolated bubbles floating in the multiverse. They might be interwoven, communicating through these quantum threads. Experiments in quantum mechanics, like those testing the Bell theorem, have shown that entanglement defies our classical understanding of reality, hinting at a deeper, more interconnected cosmic structure. Could this be evidence of parallel universes brushing up against each other, exchanging information through the quantum realm? It's a theory that challenges everything we think we know about space, time, and existence itself. And as we dive deeper into the mysteries of quantum entanglement, we're led to an even more fascinating question. What if these linked universes aren't just mirrors of our own, but worlds powered by entirely different forms of energy? That's where our journey takes us next, into the realm of universes where the very rules of energy might be rewritten. What if the energy that powers our universe is just one of countless possibilities? In some parallel realities, the very fabric of existence might be shaped by exotic forms of energy that we can barely comprehend. Take dark energy, for instance, a mysterious force driving the accelerated expansion of our universe. But what if, in another universe, dark energy behaves differently or perhaps doesn't exist at all? Imagine a cosmos where quintessence, a hypothetical form of energy that changes over time, dictates the fate of galaxies, pulling them together or pushing them apart in ways that defy our understanding of physics. These energies wouldn't just alter the universe's expansion, they could rewrite the rules of gravity, matter, and even the formation of life itself. Cosmology gives us a glimpse into how such energies might operate. In our universe, dark energy makes up about 70% of all energy, yet we still don't fully understand what it is. Now, picture a parallel universe where this energy isn't just a passive backdrop but an active, dynamic force, bending space-time into shapes we can't even visualize. Some theories suggest that these exotic energies could create universes where stars burn brighter, black holes behave unpredictably, or even where time itself flows in reverse. And this leads us to another mind-bending thought. If energy can vary so dramatically across universes, what about time? Could there be realities where time isn't linear but flows in multiple directions at once? The possibilities are as endless as the universes themselves. What if time, as we know it, isn't as straightforward as a single, unbroken line? In some parallel universes, the very fabric of reality might include multiple dimensions of time. This isn't just a wild idea, it's a theory that has been explored by physicists, and it could completely reshape how we understand cause and effect. Imagine a universe where time isn't just forward and backward, but also sideways or even diagonal. Events wouldn't just happen in sequence, they could overlap, loop, or branch in ways that defy our usual logic. Take, for example, a universe with two dimensions of time. In such a world, an event might not just have one cause and one effect. Instead, it could ripple across multiple timelines, leading to outcomes that are interconnected in ways we can't even begin to picture. Think of it like a spider's web, where every tug on one thread affects the entire structure. Theoretical physics suggests that in these universes, the rules of causality could become so complex that predicting outcomes would be nearly impossible. And here's where it gets even stranger. In a universe with multiple time dimensions, the very idea of before and after might lose its meaning. Events could influence each other in ways that seem to defy the order we're used to. For instance, what if an effect could happen before its cause? While this might sound like pure science fiction, it's a possibility that some physicists have seriously considered when exploring the boundaries of reality. Now, as we wrap our heads around these mind-bending ideas, let's take a moment to consider what's coming next. What if there were universes where the rules we take for granted, like gravity, or even the concept of space, simply don't exist? What would reality look like in a universe with no physical laws at all? Stay tuned, because that's where we're headed next. What if there's a universe where chaos reigns supreme, where the very rules that hold our reality together simply don't exist? This is the 20th concept in our exploration: universes with no physical laws. Picture a realm where gravity doesn't pull, light doesn't travel, and time itself is a meaningless concept. These hypothetical universes defy everything we know about order and structure, challenging the very foundation of our understanding of the cosmos. They're not just unpredictable, they're utterly incomprehensible by any standard we're familiar with. Philosophers have long pondered the idea of such chaotic realities. Think of Friedrich Nietzsche's concept of the eternal recurrence, where infinite possibilities replay endlessly, including those without any logical framework. Theoretical physics, too, has flirted with this idea. For instance, some interpretations of quantum mechanics suggest that at the most fundamental level, particles behave in ways that seem entirely random, almost as if they're following no rules at all. Now imagine scaling that randomness up to an entire universe. It's a dizzying thought, one that pushes the boundaries of what we consider possible. But what does this mean for us? If such universes exist, they could serve as a stark reminder of how fragile and contingent our own reality is. The laws of physics we take for granted might not be universal truths, but rather local conditions specific to our universe. This idea doesn't just challenge our scientific understanding, it shakes the very core of how we perceive order and meaning in the cosmos. As we grapple with the concept of lawless universes, it's worth turning our attention to another fascinating idea: the role of mathematics in defining parallel realities. Could mathematical principles be the true constants across universes, even in the absence of physical laws? That's where our journey takes us next. What if the universe we live in isn't made of atoms or energy, but numbers? This is the mind-bending idea behind the 21st concept, mathematical universes. Proposed by physicist Max Tegmark, this theory suggests that reality isn't just described by mathematics, it is mathematics. In other words, everything we perceive, from the stars in the sky to the thoughts in our minds, could simply be mathematical structures playing out in an abstract, number-driven framework. No physical substance, no tangible matter, just pure math. Think of it like this: imagine a video game. The world inside the game isn't made of pixels or graphics, it's made of code. The characters, the landscapes, even the physics of the game are all defined by algorithms. Now, extend that idea to our universe. What if the laws of physics, the particles, and even space-time itself are just the output of some cosmic mathematical equation? Tegmark argues that this isn't just a metaphor, it's a fundamental truth about the nature of reality. To understand this better, let's look at an example from physics. Take the equations that describe quantum mechanics or general relativity. These aren't just tools we use to predict how particles or planets behave, they're the very fabric of how the universe operates. Without these equations, the universe as we know it wouldn't exist. And if you follow this logic to its extreme, you start to wonder, could there be other mathematical structures completely different from ours that define entirely separate universes? Universes where gravity works backward or where time loops in on itself? According to Tegmark, the answer is yes, and these universes might not even require physical laws to exist. But here's where it gets even stranger. If reality is purely mathematical, then consciousness itself might just be another mathematical structure. That raises the question, could there be universes where consciousness takes on forms we can't even begin to imagine? Universes where thinking and experiencing happen in ways that defy our understanding. This idea leads us to the next concept, where we'll explore how consciousness might shape and be shaped by parallel realities. What if, in some parallel universes, reality isn't shaped by physical laws alone, but by the collective thoughts and emotions of every being within it? This is the intriguing idea behind universes governed by a collective consciousness, a shared mental framework where individual minds are deeply interconnected. Imagine a world where your thoughts, desires, and fears don't just belong to you, but ripple out and influence the very fabric of existence. In these universes, reality might be less about matter and energy and more about the power of shared intention. This concept isn't entirely foreign to us. In psychology, the idea of collective consciousness has roots in the work of thinkers like Carl Jung, who explored the notion of a shared unconscious, a reservoir of archetypes and experiences that connect all of humanity. Similarly, in philosophy, the concept of panpsychism suggests that consciousness is a fundamental feature of the universe, present in even the smallest particles. Now take these ideas and amplify them. What if, in a parallel universe, this collective awareness isn't just a subtle undercurrent, but the driving force behind how reality unfolds? In such a universe, shared thoughts and emotions could create entire environments. A collective feeling of joy might manifest as vibrant, thriving landscapes, while widespread fear could spawn dark, chaotic realms. The line between the individual and the whole would blur, as every thought contributes to the shared tapestry of existence. It's a fascinating twist on the nature of reality, one that challenges our understanding of individuality and free will. But what does this mean for the inhabitants of such a universe? Would they be more empathetic, more attuned to one another's needs, or would the constant merging of minds lead to a loss of personal identity? These are questions that push us to rethink not just the nature of parallel universes, but the very essence of what it means to be conscious. As we ponder the possibilities of universes shaped by collective thought, let's turn our attention to another mind-bending idea. What if, in some realities, cause and effect don't follow the rules we're used to? What if, instead, time flows backward and the future influences the past? This is the next concept we'll explore, a universe where causality itself is turned upside down. What if the very fabric of time worked backward in some parallel universes? Imagine a reality where the future shapes the past, where events unfold in reverse and causes are determined by their effects. This mind-bending concept, known as reversed causality, suggests that in some alternate dimensions, the arrow of time might point in the opposite direction. In these universes, the outcome of an event could ripple backward, influencing the actions that led to it. It's like watching a movie in reverse, but with everything still making perfect sense within that universe's framework. Theoretical physics offers some fascinating insights into this idea. For instance, certain interpretations of quantum mechanics propose that particles can behave as if they're moving backward in time. Experiments with entangled particles have shown behaviors that seem to defy our conventional understanding of cause and effect. While these phenomena don't directly prove reversed causality, they open the door to the possibility that such a reality could exist somewhere in the multiverse. Picture a world where you decide to take a walk because you already know you'll meet an old friend, not the other way around. It's a reality where the future isn't just predictable, it's already shaping the present. But what would life be like in such a universe? Would our sense of free will change if we knew the future was influencing our past? Or would it feel just as natural as our own forward-flowing reality? These questions challenge our understanding of time, causality, and the nature of existence itself. And as we ponder the implications of reversed causality, we're reminded that the multiverse is a place of infinite wonder, where even the most fundamental laws of physics might take on entirely new forms. Now, as we step away from the idea of time flowing backward, let's turn our attention to a universe where every possibility, no matter how unlikely, becomes a reality. A place where the concept of infinite possibilities isn't just a thought experiment, it's the very foundation of existence. What if every decision you've ever made or could ever make exists in its own separate reality? This is the mind-bending idea behind the 24th concept, universes of infinite possibilities. Imagine a cosmic tapestry where every choice, every event, and every outcome spins off into its own unique universe. In one version of reality, you might have taken that job offer across the country. In another, you stayed right where you are. And in yet another, perhaps you never even applied for it in the first place. This isn't just science fiction, it's a theory rooted in the strange and unpredictable world of quantum mechanics. At the heart of this idea is the notion that nothing is truly impossible. Every potential outcome, no matter how unlikely, could exist somewhere in the vast expanse of parallel universes. This challenges our everyday understanding of probability and chance. For example, flipping a coin might seem like a 50-50 chance, but in the grand scheme of infinite universes, there's a reality where it lands on heads every single time, and another where it never does. Quantum mechanics suggests that particles exist in a state of superposition, meaning they can be in multiple states at once until observed. Extend this idea to the universe itself, and you begin to see how every possible outcome could branch off into its own reality. But what does this mean for us? It raises profound questions about free will, destiny, and the nature of existence itself. If every possibility is realized somewhere, does that make our choices meaningless, or does it amplify their significance? And how do we reconcile the idea of infinite universes with our own limited experience of reality? These are the kinds of questions that keep physicists and philosophers up at night. As we grapple with the idea of infinite possibilities, it's worth considering how parallel universes might also resolve some of the most perplexing paradoxes in science. What happens when the laws of physics seem to contradict themselves? How can something exist and not exist at the same time? These are the puzzles we'll explore next as we dive into the role of parallel universes in untangling the knots of paradox. Now, let's tackle one of the most mind-bending questions in science. How do parallel universes help us resolve paradoxes that seem to defy logic? Take the grandfather paradox, for instance. Imagine traveling back in time and accidentally preventing your grandfather from meeting your grandmother. If that happens, you'd never be born, but if you were never born, how could you have traveled back in time to change anything? It's a classic loop that seems impossible to untangle. But what if every possible outcome of that event exists in its own separate reality? In one universe, you succeed in altering the past, and in another, you fail. Both outcomes are valid, coexisting simultaneously in the multiverse. This branching reality framework doesn't just solve the grandfather paradox, it also offers a way to understand other head-scratchers, like the bootstrap paradox, where an object or piece of information seems to have no origin. Perhaps in one universe the object is created, while in another it's borrowed from a different timeline. No contradictions, just infinite possibilities. Science fiction has long played with these ideas, from films like The Matrix to shows like Rick and Morty, but the concept isn't just for entertainment. Theoretical physics suggests that these branching realities could be more than fiction. They provide a way to make sense of paradoxes that otherwise seem unsolvable. And as we peel back the layers of this concept, it becomes clear that the multiverse isn't just a collection of alternate worlds, it's a tapestry of every possible outcome, woven together by the threads of quantum mechanics. But what if these universes don't just branch out? What if some stretch on forever, with no end in sight? That's where the next concept takes us, into the idea of infinite universes that defy our understanding of beginnings and endings entirely. What if time itself behaves differently in other universes? Imagine a reality where the ticking of clocks, the aging of stars, and the very concept of beginnings and endings simply don't exist. This brings us to the 26th astonishing concept, universes with no end. Unlike our own universe, which began with the Big Bang and may one day face heat, death, or collapse, some parallel universes could exist eternally. No starting point, no conclusion, just an infinite, unbroken stretch of existence. This idea turns our understanding of time on its head. In our world, time is linear, a straight arrow moving from past to future. But in these eternal universes, time might loop endlessly, stretch infinitely, or even dissolve into a state where it has no meaning at all. Cosmologists have theorized about such possibilities, drawing from models like the cyclic universe theory, which suggests that universes might undergo endless cycles of expansion and contraction. Or consider the idea of a steady-state universe, where new matter continuously forms to maintain a constant density, creating a cosmos that never truly begins or ends. What's even more fascinating is how this challenges our perception of existence itself. If a universe has no start or finish, does it even have a history? Could life in such a universe experience time as we do, or would it be something entirely alien? These questions push the boundaries of both science and philosophy, forcing us to rethink what it means to exist within the fabric of reality. As we ponder the mysteries of timeless universes, another intriguing possibility emerges. What if these parallel realities aren't just eternal, but also made of entirely different forms of matter? This leads us to the next concept, where we'll explore the idea of universes composed of exotic materials, substances so strange they defy everything we know about the building blocks of reality. What if the rules of matter itself were completely different in another universe? Imagine a place where objects don't just have mass, they could have negative mass, or even stranger forms of matter that behave in ways that seem impossible in our reality. This is the 27th concept, universes filled with exotic matter. In these parallel realms, the very fabric of existence might be built from materials that challenge everything we know about physics. Take negative mass, for example. In our universe, mass creates gravity, it pulls things together. But in a universe with negative mass, matter could repel instead of attract. Picture a planet made of this material. Instead of forming a sphere under its own gravity, it might expand outward, defying the natural order we're familiar with. Or consider strange matter, a hypothetical form that could be denser and more stable than anything we've ever encountered. If such matter exists in another universe, it might form stars and galaxies that operate under entirely different rules, creating cosmic structures we can barely imagine. Particle physics gives us a glimpse of how wild these possibilities could be. In experiments, scientists have observed particles that seem to behave in bizarre ways, hinting at the potential for exotic matter. For instance, certain subatomic particles in quantum mechanics appear to exist in multiple states at once, a phenomenon that could be amplified in a universe where exotic matter dominates. These materials wouldn't just reshape the physical world, they could redefine what we think is possible, opening doors to realities where the laws of nature are unrecognizable. And if you think that's mind-bending, just wait. The next concept takes this idea even further, exploring how some universes might not just have exotic matter. They could host multiple realities within them, each with its own set of rules and possibilities. What would that even look like? Well, let's dive in. What if the universe we know is just one layer of a far more intricate cosmic tapestry? Imagine a reality where multiple versions of existence overlap, each governed by its own unique set of physical laws. This is the fascinating idea behind universes with multiple realities. In such a cosmos, it's possible that what we perceive as a single, unified reality is actually a blend of countless others, each operating under entirely different rules. Some might have gravity that pulls sideways, while others could have time that flows backward. The possibilities are as endless as they are mind-bending. Theoretical physics offers some intriguing frameworks to explore this concept. For instance, the idea of brain cosmology suggests that our universe could be one of many membranes floating in a higher dimensional space. These branes could intersect or overlap, creating regions where multiple realities coexist. Picture a stack of transparent sheets, each representing a different reality. Where they overlap, the rules of one might bleed into another, creating zones where the impossible becomes possible. This layered cosmos doesn't just challenge our understanding of physics, it redefines what it means to exist. In one reality, stars might form in perfect spirals, while in another, they could scatter randomly like confetti. These overlapping realities could explain phenomena that seem inexplicable in our own universe, like dark energy or quantum entanglement. They might even hold the key to understanding why the fundamental constants of nature, like the speed of light or the strength of gravity, are what they are. But what does this mean for us? If multiple realities are intertwined, could we ever detect or interact with them? Some theories suggest that faint echoes of these parallel worlds might be observable in the cosmic microwave background radiation, the afterglow of the Big Bang. Others propose that tiny anomalies in particle physics experiments could be glimpses into these overlapping realms. While we're far from proving their existence, the mere possibility opens up a universe of questions and perhaps answers. And speaking of questions, this concept naturally leads us to ponder something even more profound. If multiple realities can coexist, how does this shape our perception of free will? Are our choices truly ours, or are they influenced by the overlapping rules of countless other universes? That's a mystery we'll explore next. But what if every choice you make doesn't just shape your life, it creates an entirely new reality? This is where the concept of free will intersects with the mind-bending idea of parallel universes. In a deterministic universe, everything is preordained, like a cosmic script where every event follows a predictable chain of cause and effect. But what if, instead of a single path, every decision you make spawns a new branch of reality? Imagine standing at a crossroads. In one universe, you take the left path, and in another, you go right. Both versions of you exist simultaneously, living out the consequences of those choices in separate realities. This idea, often linked to the many worlds interpretation of quantum mechanics, suggests that free will isn't just an illusion, it's a force that generates infinite universes. Philosophers have long debated the nature of free will, but parallel universes offer a fascinating twist. If every possible outcome exists in some alternate reality, does that mean we're truly free to choose, or are we simply navigating an endless web of possibilities? Quantum mechanics adds another layer to this puzzle. At the subatomic level, particles exist in a state of probability until observed, and every possible outcome of their behavior could manifest in a parallel universe. This challenges the deterministic view of the universe, suggesting that randomness and choice play a fundamental role in shaping existence. Think of it like flipping a coin. In our world, it lands on heads or tails, but in the multiverse, both outcomes happen just in different realities. This raises profound questions about responsibility and identity. Are we the sum of all our possible selves scattered across countless universes? And if so, what does that mean for the concept of free will? These ideas blur the lines between science and philosophy, inviting us to rethink what it means to make a choice. As we venture deeper into the multiverse, another intriguing question emerges. What if some of these realities exist outside the constraints of time as we know it? Imagine a universe where time doesn't flow linearly or doesn't exist at all. This brings us to the next astonishing concept: universes where time is not a factor, and existence unfolds in ways that defy our understanding of past, present, and future. What if time, as we know it, doesn't exist everywhere? Imagine a universe where clocks don't tick, seasons never change, and everything exists in a single, unchanging moment. This is the mind-bending idea behind timeless universes, parallel realities where time simply doesn't flow. In these universes, there's no past, no future, just an eternal now. It's a concept that challenges everything we think we know about existence. Theoretical physics offers some fascinating insights into how this might work. For example, some scientists suggest that in a timeless universe, the laws of physics operate differently. Without time, there's no cause and effect, no aging, and no decay. Everything exists in a state of perfect stillness. It's like a photograph frozen in an infinite moment where nothing ever changes. Think about that: no birth, no death, no growth, just an endless, unbroken state of being. But how could such a universe even exist? One way to think about it is through the lens of mathematics. In equations that describe the fabric of reality, time is just another variable, a dimension that can be manipulated or even removed. If you take time out of the equation, you're left with a universe that exists purely in space, unchanging and eternal. It's a concept that stretches our imagination to its limits, forcing us to rethink what it means to exist at all. And here's where it gets even more intriguing. If timeless universes are possible, what does that mean for our understanding of reality? Could our own universe one day transition into a timeless state? Or are there already regions of existence where time has no meaning? These questions push us to explore not just the nature of parallel worlds, but the very fabric of reality itself. As we ponder the idea of timeless universes, it's worth considering how space itself might play a role. What if the absence of time leads to entirely new forms of space, dimensions that are as foreign to us as timelessness? This brings us to the next concept, where we'll explore universes with radically different spatial structures, reshaping our understanding of the cosmos once again. What if the space we know, the straight lines, the flat planes, the familiar three dimensions, isn't the only way reality can be structured? Imagine a universe where space itself is curved, twisted, or folded in ways that defy our everyday experience. This isn't just science fiction, it's a serious possibility in the study of parallel universes. Some theories suggest that alternate realities might not just have different laws of physics, but entirely different geometries. Picture a world where space loops back on itself, creating closed, finite universes, or one where dimensions are stretched and warped into bizarre shapes we can barely comprehend. In our universe, gravity curves space-time, as Einstein's theory of general relativity shows. But in these exotic universes, space might be curved or folded on a much larger scale, creating topologies that are entirely alien. For example, a universe with a closed geometry might curve back on itself like the surface of a sphere, meaning if you traveled far enough in one direction, you'd eventually end up where you started. On the other hand, an open universe might stretch infinitely, with space expanding faster than light can traverse it. And then there's the idea of higher dimensions universes with 4, 5, or even more spatial dimensions, where the very fabric of reality could be far more complex than anything we've ever imagined. Cosmology offers some intriguing hints about these possibilities. For instance, the shape of our own universe is still a topic of debate. Is it flat, as some measurements suggest, or could there be subtle curvatures we haven't detected yet? If parallel universes exist, they might hold the answers to these questions, and they might show us just how strange and varied reality can truly be. these exotic geometries wouldn't just change how space looks, they'd fundamentally alter how matter, energy, and even time behave. Imagine a universe where parallel lines converge or diverge unpredictably, or where the very concept of distance becomes meaningless. But what does all this mean for us? If such universes exist, they could challenge our understanding of what's possible, revealing realities that are not just parallel, but profoundly different in their very structure. And speaking of profound differences, this brings us to one of the most fascinating questions in cosmology. Why is our universe so perfectly fine-tuned for life? Could the existence of parallel universes hold the key to answering that? Stay with us as we explore this next mind-bending concept. What if the delicate balance of our universe, the precise constants and conditions that allow life to exist, isn't just a cosmic coincidence, but a result of countless parallel universes, each with its own unique set of rules? This is where the idea of fine-tuning and parallel universes comes into play. Imagine a vast multiverse where every possible variation of physical laws and constants exists. In some universes, gravity might be stronger, making stars burn out too quickly for planets to form. In others, the speed of light could be slower, preventing complex chemistry from ever arising. Yet here we are, in a universe where everything seems perfectly calibrated to support life. Why? This is where the anthropic principle steps in. It suggests that we observe this fine-tuning because, well, we're here to observe it. In a multiverse filled with infinite possibilities, it's inevitable that at least one universe would have the right conditions for life, and that's the one we're in. Think of it like a cosmic lottery. Our universe just happens to be the lucky winner, while countless others remain barren or chaotic. Cosmology offers intriguing hints that support this idea. For instance, the cosmological constant, a value that determines the rate of the universe's expansion, is so finely tuned that even a slight variation would make galaxies impossible to form. In a multiverse, this precision isn't so mysterious, it's just one outcome among many. But what if the multiverse isn't just a collection of universes with different constants? What if some universes exist without boundaries altogether, no edges, no limits, no defined structure? That's where our next concept takes us, into the mind-bending realm of universes that defy our understanding of space and time. What if the universe you're sitting in right now, this one, with its stars, planets, and galaxies, isn't the only one out there? And what if some of these other universes don't even have edges or boundaries? This is the mind-bending idea behind the 33rd concept, universes with no boundaries. Picture a space that never ends, stretching infinitely in every direction. No walls, no borders, just endless expansion. It's a concept that flips our entire understanding of space and containment on its head. In our own universe, we're used to thinking of space as something contained within a framework. Galaxies have edges, planets have surfaces, and even the observable universe has a limit to how far we can see. But what if there's a parallel universe where none of that applies? Theoretical physics offers some intriguing insights here. For instance, the idea of an infinite multiverse suggests that some universes could be boundless, with no physical or spatial constraints. This means that in these universes, space doesn't just expand, it stretches forever without any end point. Think of it like this. Imagine you're walking on a beach, and instead of the shoreline eventually ending, the sand just keeps going infinitely in every direction. No matter how far you walk, you'll never reach a boundary. That's what a boundary-less universe might be like. It's not just an abstract idea. It's a concept that challenges the very foundation of how we perceive reality. If a universe has no boundaries, does it still have a center? Does it even make sense to talk about inside and outside in such a place? These are the kinds of questions physicists grapple with when exploring this idea. And here's where it gets even more fascinating. Some theories suggest that boundary-less universes could exist alongside our own, each one a self-contained, infinite expanse. The implications are staggering. If such universes exist, they could host entirely different laws of physics, different forms of matter, or even different dimensions of time. It's a concept that pushes the boundaries, pun intended, of what we consider possible. Now, as we move forward, let's consider another intriguing possibility. What if some universes don't just have different physical laws, but entirely different forms of existence altogether? What if reality itself takes on a shape we can't even begin to comprehend? That's where our journey takes us next. What if the very fabric of existence could take on forms so alien to our own that they defy everything we think we know about reality? This brings us to the 34th concept, universes with entirely different forms of existence. In some parallel realities, life might not be bound by the physical bodies we know. Instead, it could exist as pure energy, flowing and interacting in ways that seem almost magical to us. Imagine a universe where consciousness isn't tied to a brain but is a field of energy, seamlessly connected across vast cosmic distances. Or consider the possibility of information-based realities, worlds where existence itself is defined not by matter or energy, but by the exchange and processing of information. In these universes, everything from the smallest particle to the largest galaxy could be encoded in a vast, interconnected network, like a cosmic supercomputer running the ultimate simulation. Theoretical physics often toys with these ideas, suggesting that our own universe might be a kind of holographic projection, a lower-dimensional shadow of a higher-dimensional reality. Philosophers have also pondered these questions for centuries. What if existence isn't limited to what we can touch, see, or measure? What if there are dimensions of reality that operate on principles so foreign to us that they're nearly impossible to comprehend? These aren't just thought experiments, they're glimpses into the profound mysteries that parallel universes might hold. As we explore these mind-bending ideas, we're building towards something even bigger. The final concept will uncover ties together all the astonishing possibilities we've discussed, offering a glimpse into how these parallel realities might coexist, interact, and even shape one another. It's a revelation that could change the way we think about everything from the nature of existence to the very meaning of reality itself. As we bring this exploration of parallel universes to a close, let's take a moment to reflect on the extraordinary ideas we've uncovered. From the mind-bending notion of infinite realities coexisting alongside our own to the possibility of branching timelines shaping every decision we make, these concepts stretch the limits of what we thought was possible. They challenge us to rethink not just the universe, but our place within it. Think about it. If every choice spawns a new universe, then somewhere out there, an alternate version of you is living a life entirely different from the one you know. And if the multiverse is a vast cosmic tapestry woven with infinite threads of existence, then what does that mean for the idea of fate or free will? These ideas don't just reshape our understanding of reality, they force us to confront profound questions about identity, purpose, and the very nature of existence. What's truly remarkable is how these theories bridge the gap between science and philosophy. They remind us that the universe is far stranger and more mysterious than we can imagine. And while we may never have definitive proof of parallel universes, the journey of exploring these ideas is itself a testament to human curiosity and ingenuity. It's a reminder that the search for knowledge is never truly finished. As we wrap up, here's a thought to ponder. What if the boundaries of reality are not fixed but fluid? What if every moment holds the potential for infinite possibilities? Albert Einstein once said, "The most beautiful thing we can experience is the mysterious." It is the source of all true art and science. Let these words inspire you to keep questioning, keep exploring, and keep marveling at the wonder of the cosmos. Now, we'd love to hear from you. What do you think about these mind-bending concepts? How do they shape your perspective on reality? Share your thoughts in the comments below, and if you're hungry for more, check out the resources linked in the description. The universe is vast, and the journey is just beginning. As we wrap up this journey through the mind-bending world of parallel universes, let's take a moment to reflect on what we've uncovered. The idea that our universe might be just one of countless others isn't just a wild thought experiment. It's a concept that could fundamentally change how we see reality itself. From the quantum level to the cosmic scale, the implications are staggering. Imagine a reality where every decision you've ever made plays out in infinite variations, or where entirely different laws of physics govern existence. These aren't just abstract ideas, they're windows into a deeper understanding of the cosmos. What's truly exciting is how this knowledge could reshape not only science but also philosophy and even our daily lives. Think about it. If parallel universes exist, what does that mean for free will, for the nature of identity, for the very concept of reality? These questions challenge us to think bigger, to question the boundaries of what we know, and to embrace the mysteries that lie beyond. And while we may not have all the answers yet, that's where the beauty lies in the journey of discovery. So, what's next? The exploration of parallel universes is far from over. With every breakthrough in physics, every new theory, and every technological advancement, we get closer to unlocking these cosmic secrets, and you can be part of that journey. Stay curious, keep asking questions, and dive deeper into the wonders of the universe. If you've enjoyed this video, don't forget to hit that subscribe button and share it with someone who loves pondering the big questions. Together, let's keep exploring the infinite possibilities that lie just beyond the horizon of our understanding. The universe, or should I say, universes, are waiting.